So, hello, dear students. Good afternoon to all. Good afternoon. So, can you see me? Is my voice audible to all of you? Just let me know. Yeah. And you can see the screen also, right? Thank you. Thank you so much. Thank you, Bhavna. Thank you, Ankusha. Yes, yes. Yes, let's wait for 1 more minute so that others can join and then start the class. Okay. So let's start the class. So in last class, we were discussing about the general organic chemistry, right? So some introduction and what else we have seen? We have seen the structural representation and some classifications of organic compounds. We have seen all those things we have discussed in the last class. And in today's class, as I have told you, so we are going to deal with the nomenclature, which is called as naming of organic compounds. Okay. So there are two different types of naming. One is called as common name and the other one is called as IUPAC name. So the other name for common name is called as trivial name. Okay. So the common name is otherwise called as trivial name. So let's discuss the common names of organic compounds first, and then we will discuss about the IUPAC names. Got it? So moving on to the common names or the trivial names of the system. So from where does the common name come from? So you can see a picture on the screen, right? So what it is, they are citrus fruits. So the compounds or the chemical which is present in that particular citrus fruit is called as citric acid. So the name citric acid has derived because the fruits are citrus in nature. Got it? And coming to the next thing, yeah, the organic compounds were designed. Sorry, excuse me. Organic compounds were assigned names based on their origin or certain properties. Got it? So the name citric has origin from the name citrus. So you can see a red ant. Okay. So there is a sting for an ant, right? So these are the sting of the ant. And so if an ant bites you, so that the place get enlarged or they get bulged out, no? Can any one of you tell me why it is getting like that when a red ant bites you? Yes, very good, Rashmi. So some chemical is again present there in the sting of the red ant. What is the name of that chemical? It is called as formic acid, as you have told. So from where does the formic acid name come from? So the name of the Latin word for red ant is formica. Okay, so now we are calling it as red ant, and in Latin it is called as formica, and that's why we are naming the chemical as formic acid. Okay, it has come from the origin of that particular system. From where do we get it? So this is how the common names or the trivial names comes into existence here in the organic chemistry. And let's see some more common names of some organic compounds. Got it? So you can see a tabular column on your screen. So CH4 is named as methane. And if you have 4 carbon, it is N-butane. And 4 carbon with branched chain is called as isobutane. And the other one is also having 4 carbon, but it is 5 carbon, it is neopentane. And HCHO is formaldehyde. Since CHO group is there, it is called as formaldehyde. And C double bond O containing system is called as acetone. CHCl3 is chloroform. COOH group, so it is called as acetic acid. And C6H6, we all know that it is benzene. And phenyl group containing OCH3 group is called as anisole. And phenyl containing NH2 is called as aniline. And phenyl containing COCH3 is called as acetophenone. And here we are having an ether group, and this is methyl and this is ethyl. So it is called as ethyl methyl ether according to the alphabetical list. Got it? So these are some of the common names of some organic compounds. So let's discuss in detail with the functional groups present here in each compounds, etc., in the upcoming slides. Okay. So these are just the examples that we have to go through. You can see this in your book also. Okay. So now let's go for the IUPAC. So any doubt? Any of you have in the common name? So it is basically derived from its origin or the properties which it does. So basically it is derived from the origin, okay, from the compound we are taking. Name of the compound from which we are taking, that name is given to the compound also. Any doubt, students? Any of you have any doubt in the common name? So anybody can understand the common name. Anybody in the sense, the shopkeepers who is selling the chemical compounds. So anybody can understand the common name. But only very few people means who know the chemistry, they only can understand the IUPAC name. Okay. So the what is IUPAC name? And let's see the okay, Srujana, you have shared something. Okay. She done by mistake. Okay, so coming to the IUPAC system of nomenclature, it is a systematic method of naming an organic compound, and the full form of IUPAC is International Union of Pure and Applied Chemistry. This is the full form of IUPAC. Okay. So the names of IUPAC, they are correlated with the structure such that the reader or listener can deduce the structure from the name. So if I give you the name, you can derive the structure. You can get the structure. So how can you get the structure? By studying the rules of the IUPAC. Got it? So it is a systematic method of naming a compound. So where all chemists can do it. Okay. So let's see an example. This is ethane. So why it is called as ethane? Because it is having only single bonded system. So it is an alkane. Since there are only 2 carbons present in it, it is called as ethane. Got it? So I'll tell you the root word and all in the upcoming slides. So you can take the screenshot of it or you can take the note of this. The full form of IUPAC is very important. Okay. And it is a systematic method. Now coming to systematic name of an organic compound is derived by identifying the hydrocarbon and the functional group attached to it. So how can we deduce the name of the particular system or the structure of a compound from a particular name? So by identifying the hydrocarbon and the functional group attached to the hydrocarbon in the given molecule. So I'll show you an example. So this is the 6 carbon containing hydrocarbon. 6 carbon containing hydrocarbon, which is called as parent chain. And to this parent chain, we have 3 substituents attached to it. Okay. So CH3 is called as methyl, which is a branch to this parent chain. And OH and Cl, those 2 are called as functional group present in this molecule. Okay. And the compounds containing carbon and hydrogen only are called as hydrocarbon, as we all know it very well. And by identifying the functional groups and the substituents attached to the parent chain, you can able to get the name of the given organic compound. Okay. So if you're having only carbon-carbon single bond in your molecule, then it is called as saturated hydrocarbon. If you're having carbon-carbon double bond or carbon-carbon triple bond, then it is called as unsaturated hydrocarbon. Okay. Unsaturated system. Got it? Unsaturated means you can still do the reaction. You can still break the double bond, or you can still break the pi bond which is there in that system, and you can do the reactions over it. But in case of carbon-carbon single bond, the single bond is more strong. Single bond is more strong than the double bond. So you cannot break this bond so easily. Okay. So this is saturated already. Whereas the pi bond is little bit weak where you can break the system. Okay. So what is the point you are getting from this particular topic? To get the name or to derive the name for a given compound, first you have to identify the hydrocarbon chain present in it and the functional group attached to the parent chain. Got it, students? Shall I move on to the next slide? If you're having any doubt here, you can ask me. If you're having any doubt, you can ask me. No doubt? Everything is clear? If it is clear, just put yes in the chat box. I'll go for the next slide. Students, I am audible to all of you, right? Am I audible? Thank you, Anvisha and Bharat. Fine. So the IUPAC name for a homologous series of such compound is called as alkane. Thank you so much, students. So what is the skeletal structure of an IUPAC system? So you can see the skeletal. So this is the skeletal structure. This is the skeletal structure of an IUPAC nomenclature system. Okay. So in the IUPAC name, you will have a secondary prefix and primary prefix. There will be a root word, primary suffix and secondary suffix. So the part which is coming after the root word, they are called as suffix, and the one which is present before the root word, they are prefixes. Okay. So who can be the root word and what is root word? Number of carbon atom in the parent chain is called as root word. Like in the last example, we have seen, no, there were 6 carbon atoms in the parent chain. So it is called as hexane. I'll tell you the root word in the next slide. Okay. And primary suffix, who are the primary suffix? They represent the unsaturated system or the saturated system. It can be alkane, alkene and alkyne. If your compound contains only carbon-carbon double bond, then you have to end the name with ANE because it is an alkane. If your compound has C double bond C, then what you have to do? You have to end the name by ENE because it is an alkene. If it ends with triple bond, then it is alkyne. So you have to end the name with YNE. So these are the primary suffixes. Alkane, alkene and alkyne. And the secondary suffixes are your main functional group. So in the last example, we had 2 functional groups, right? One is OH and the other one is Cl. Mainly OH acts as a functional group. Cl, in most of the cases, they do not act as a functional group. It is also called as substituent only. Now, if the compound contains OH, then it is the alcohol. If it is an alcohol, then you have to end the name with OL. I'll tell you how to give the suffix and what are the suffix for corresponding functional groups in the upcoming slides. Okay. So mainly all the functional groups will be your secondary suffix. Got it? Hydrocarbon part will be the primary suffix and the functional group will be your secondary suffix. Now, who are the primary prefix? It can be your cyclic compound. Like in yesterday, in the last class, we have discussed, no? Cyclopropane, cyclopentane, cyclohexane. So if the compound is cyclic, you have to use the primary prefix. And the secondary prefix are the substituents with locants. So who are the substituents? So in the last case, CH3 was there. So in the branch, so that is a substituent. And Cl was there. That is a substituent. So those are the substituents which has to be written at first in your IUPAC nomenclature. Okay, substituents with locants they are saying. I will tell you what is locant while discussing the rules for IUPAC. Got it? So these 5 consist of the skeletal structure of a given IUPAC system. Okay. So I'll go for the next slide. Coming to the root word. So if you're having only one carbon in your compound, then the root word for that compound is meth. Okay. Suppose if it is an alkane, then you can name it as methane. If it is an alkane and it contains 2 carbon, then it is called as ethane. 3 carbon, propane, butane, pentane, hexane. Like this, it goes on. Can anyone tell me the root word for 7 carbon system? What is the root word for 7 carbon system? Any idea? Any of you have? Very good. It is called as heptane. What about 8? Very good, students. What about 8? For 8 carbon, it is octane. What about for 9 carbon? What about for 9 carbon? It is nonane. Very good. And what about for 10 carbon? For 10 carbon, it is decane. Good. So you all are aware of these, I think. Okay. Fine. So this is decane. Good, good, good. So these are the root words. These are the root words for a system. And coming to alkane. So here you can see the alkane with 2 carbon and it is having only one bond between 2 carbons. So the single bond of the system is actually alkane. Since it has 2 carbon, it is called as ethane. Okay. And coming to alkene, so we have C2H4 here. Yes, Rujana, it is ethane. And since it has carbon-carbon double bond, it is ethene. And coming to alkyne, who are alkynes? Triple bonded system, right? If a system has carbon-carbon triple bond in it, then it is called as ethyne. Very good. It is ethyne. It is ethyne. Good. Fine. So I'll go fast. As you all know the basics of this very well, I'll go fast. So coming to the straight chain hydrocarbons, how to name the straight chain hydrocarbons? The names of such compounds are based on their chain structure. Okay. And for hydrocarbons, basically for alkane, it ends with ANE. It ends with ANE. So just now we were discussing about this, right? Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. And if you're having 20 carbon, it is called as icosane. And if you're having 30 carbon containing hydrocarbon or 30 carbon containing alkane is called as triaconate. What it is? Triaconate. Actually, it is triaconate. Okay. These are the nomenclature for straight chain hydrocarbon. No branching is here. Only chain. Only the parent chain is there. Everything is there in the linear chain. So, like this, we are naming for the straight chain hydrocarbons. And what about for the system which has branches? So, the nomenclature for branched chain alkanes has to follow some set of rules. They have to follow some set of rules because we do have branches in it, right? So, the small chain of carbon atoms, which are nothing but the branches, they are attached to one carbon or more than one carbon in the parent chain. So, you can see. So, an example is given to you on the screen. So, the straight chain is the parent chain and this is the branch attached to this particular straight chain, right? So, it is a branch. And here you see, so this is our straight chain and these two are the branches. Always the one which is there in the linear format will not be the straight chain, or the parent chain or the straight chain consists of more number of carbons. Okay, the parent chain is the chain which consists of more number of carbons. You should not take the linear chain always. You have to take the chain which contains more number of carbons in it. Okay, and in the first example only one branch is there. In second example we have 2 branches and they are called as alkyl groups. The branches are called as alkyl groups. And how do we get that alkyl group? From where does it come? So it is coming from the alkanes. Okay. For example, if I'm taking methane, if I remove one of the hydrogen, one carbon hydrogen bond is getting broken down and then hydrogen is removed, and by doing so I am getting CH3 and one bond. So this is called as methyl. So here I can substitute any atom or any group. Okay. So basically the CH3 part is called as alkyl. Here it is called as methyl. Since we are deriving it from methane, it is called as methyl. If it is ethane, it is ethyl. If it is propane, it is propyl. Right? So basically from alkane, if you remove one hydrogen, you will get alkyl. Okay. And for one carbon containing system, that is methane, only one alkyl group is formed, which is methyl. And for two carbon containing alkane, ethane also, only one alkyl group, which is called as ethyl. So how do we get that? So you can see some alkyl groups from methane, methyl, ethane, ethyl, propane, propyl, and butane, butyl, decane, decyl. Okay. So for methane and ethane, only one alkyl groups we have. And from propyl onwards, we do not have only one propyl, one alkyl, which you can see here. Propane also forms one more alkyl group. Can any of you name that another alkyl group which is getting formed from propane? One alkyl is shown to you for propyl. One more is there. Any idea about that? What is the name of the other alkyl group which is formed from propane? And butyl also contains 4 alkyl groups. Propane contains 2 alkyl groups and butane contains 4 alkyl groups. Only one is shown to you on the screen. Okay. So you tell me the other alkyl group which is will be formed for propane. Any of you have any idea? No idea? Okay. Okay. Sorry. Just a second. Okay. So I'll tell you. Very good, Anvisha. It is isopropyl. So how do we get isopropyl from propane? How do we get isopropyl from propane? So this group is called as isopropyl. And how do we get this isopropyl from propane? So I'll tell you. So the formula from branched, yeah, good. So we are taking the alkane, which is propane, CH3, CH2, CH3. So this is called as propane, right? So from propane, what we have to do? We have to remove hydrogen from the second carbon. Very good, Rashmi, good. So there are 2 different types of hydrogen present in this propane. One is the terminal hydrogen. By removing the terminal hydrogen, I can get on alkyl group, which is called as N-propyl of formula CH3, CH2 and CH2 and one bond. Okay. So this is called as N-propyl. N represents normal. Okay. Normal propyl. And there is also one more type of hydrogen here, which is the internal hydrogen. And by removing one of the internal hydrogen, I'll get one more compound, right? It is CH3, CH bond and CH3. So now this is called as isopropyl. This is called as isopropyl. Okay, removing the terminal hydrogen leads to N-propyl and removing the second hydrogen or the internal hydrogen leads to the isopropyl. So this is how we are getting different alkyls. So the concept is the number of different types of hydrogen produces the different types of alkyl groups. So in case of methane and ethane, we had only one type of hydrogen. So that's why only one alkyl group is produced. And here in this case, since 2 types of hydrogens are there, it is forming 2 different types of alkyl groups. And coming to 4 carbon containing system, which is butane. And from butane, we can produce 4 different alkyl groups. And how those 4 alkyl groups are produced. You can see it on the screen. One is secondary butyl, and the other one is isobutyl, and the other one is tertiary butyl. Fourth one is N-butyl. Actually, N-butyl comes first, right? So I'll tell you. So what is the formula for butane? C4H10, right? CH3, CH2, CH2, and CH3. So this is butane. Okay. So the first combination or the first compound will be formed by removing the terminal hydrogen. So what you do, you remove one of these hydrogen. So what you will get? It is CH3, CH2, 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 and one bond you will have. No, this is called as N-butyl. This is called as N-butyl. And secondly, what you do, you remove the hydrogen from this. Remove the hydrogen from the last before carbon. So what we will get? We will get CH3, CH2, CH, and one bond, and CH3. So this structure is called as secondary butyl. This is called as secondary butyl. Okay. So thirdly, what you have to do, you have to take this methyl group and take this methyl group and substitute or put it to the second carbon. So replace one of the second hydrogen by this methyl group. Okay. What you will get? Already the CH3 is there. Now to the second carbon, we are removing one hydrogen and replacing it with CH3. And the third CH2 is there and a bond is formed. Okay. This compound is called as isobutyl. This is called as isobutyl. And from the same butane, here in tertiary butyl structure, you should not have this hydrogen. So how to get the tertiary butyl? So take one carbon and attach 3 methyl groups to it. So you will get tertiary butyl, which you can see it on the screen. Okay. So the straight chain with the CH2 bond is called as N-butyl. So the straight chain with this branch on the second carbon is called as secondary butyl. CH bond is secondary butyl. And one branch with the CH2 bond is called as isobutyl. And a carbon attached with the 3 methyl group is called as tertiary butyl. CH is secondary, CH2 is iso, and the C is tertiary. Okay. So this is how we are deriving 4 butyl groups from butane. Okay. So you have to study. So there should not be any confusion here in producing the alkyl groups. Okay. So all these are very basic. If you didn't study these alkyl groups, you have to study. At least till butane, you have to study. Students, any doubt you have? Do any of you have any doubt? Will you all be able to take the 4 alkyl groups from butane? If you have any doubt, you can ask me now. If it is clear, put yes in the chat box. So, yes. Okay, Rashmi. Others also, yeah. Others also, you go and revise this ones, okay? Organic chemistry have to be studied every day. You have to study organic chemistry. If you daily practice organic chemistry and if you daily study and if you're solving questions, you can master organic chemistry. As I've already told you in the first class while discussing the syllabus, I told you, organic chemistry is the major part in NEET as well as for JEE also. Okay, the major portion will be from organic for JEE also. So you have to concentrate more on this and you have to be very strong in the basics. Basic in the sense, this particular general organic chemistry lesson and the hydrocarbons lesson. If you are thorough with this, with these 2 lessons, thorough in the sense not memorizing the reactions, understanding and then memorizing. Okay, conceptual understanding is very important. Just understand and learn every day, you will not forget. And you can apply it for any system. Got it? So how many alkyl groups were there for propane? How many alkyl groups can be generated for propane? 1 or 2 or 3? Yes, 2. Good. How many for butane? 4. And one more thing I have to tell you, for 5 carbon system. Yes, yes. Yes, yes, students. Yes. So for 5 carbon alkane, which is called as pentane, so one alkyl group can be produced from pentane, which you can see on the screen. There are a number of alkyl groups that can be produced for pentane, but one among them is very important. The one which you are seeing on the screen. This is very important. Pentyl, neopentyl. Okay. So the way which we have prepared tertiary butyl, we took 1 carbon and we have attached the 3 alkyl groups to it and we got tertiary butyl. No. So what happened? Just a second. Yeah. So the same way for 5 carbon containing system, you draw the tertiary butyl group first. So this is still tertiary butyl. And to the carbon which is there in the center, you attach 1 more CH2 and put a bond. You will get 5 carbon containing alkyl group and the name is called as neopentyl. This neopentyl is very important for you. Okay. So the other pentyl groups, they are not that important. This is very important. You should be able to find out the neopentyl group if a compound is given to you in the question paper. Okay, students, clear? CH3 is methyl and C2H5 is ethyl. C2H5 can also be written as CH3 and CH2 bond, right? You can also write like this. And for propyl, we had 2 combination. For butyl, I told you 4. And for pentyl, I gave you 1, which is called as neopentyl. So all these 5 alkyl groups are very, very important to name a given hydrocarbon and also for all the organic chemistry. Okay. Shall I move on to the next slide? Shall I go with the next concept? Yes. Now, let's move on to the rules to name the branched chain alkenes. Okay. Rule number 1. Longest carbon chain in the molecule is identified. What is the first rule? You have to find out the more number of carbon containing chain, which is called as longest chain. So a compound is given to you. So you can see the hydrocarbon chain, which is the longest chain, which is the longest chain, which is the more carbon containing chain. Straight chain. Straight chain is the longest chain, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon in it. If we take this chain as longest chain, so 6, 7, 8, here only 8 we are having. So 8 is not a bigger number, no? So 9 is bigger. So this is the longest chain, more carbon containing chain. One minute. Just a second, students. I'll share again. Sorry for the interruption. Just wait for a second. Just a second. So all of you can see the screen, right? So is my screen visible to all of you? Yes. Okay. So you can see 9 carbon containing system over there on the screen, and the second carbon. Yes. So the second system you see, this type of numbering is wrong. Only the first numbering is correct, as I have told you. So this type of numbering is wrong because it contains only very less number of carbon, which is 8. So that is wrong. Only the first way of numbering is correct. And that is the longest carbon chain in the molecule. So first we are identifying this. Then coming to the second rule, the numbering is done in such a way that the branched carbon atoms get the lowest possible numbers. So we have numbered the chain. Now how to number them? From left to right or right to left? So for that, we have to look into the branches. So in that system, so the compound is same only. The compound is same only, which I have showed you on the previous slide. So only carbons are shown here. Hydrogens are not shown. Okay. So here we have 2 branches, right? So what is the name of this particular alkyl group? If an alkyl group contains only 1 carbon, it is called as methyl. And this is called as ethyl. Now we have to look into the carbon to which this alkyl groups are attached. So methyl is attached with second carbon and ethyl is attached with 6 carbon. Now you add those 2 numbers. 2 plus 6. What is 2 plus 6? 8, right? And if you are numbering from right to left, if the parent chain is numbered from right to left, then also you have to check for the number. Here we are getting 8 and here we are getting 4. So what is 8 plus 4? 8 plus 4 is 12. So which is the correct way of numbering? So while adding the carbons to which the substituents are attached, you should get the lowest possible number. You should get the lowest possible number. So which is lowest? 8 is lowest, right? So this way of numbering is correct. The first compound is having the correct numbering. So this rule is called as locant rule. This rule is called as locant rule. Getting the very least number while adding the substituent attached to carbons. Okay. So you see the 2 plus 6 is 8, which is correct. And 4 plus 8 is 12, which is wrong. Clear, students? First you find the parent chain and number accordingly. Now, third rule. Names of alkyl groups attached as a branch are then prefixed to the name of the parent alkane, and position of substituents is indicated by appropriate number. Okay. So we have to start with the branches, names of the alkyl groups. So as I have told you, this is methyl and this is ethyl. So names of the alkyl groups are attached as a branch. So 2 branches we are having and are then prefixed to the name of the parent alkane. So you have to write those alkyl groups which are branches as a prefix. From that prefix only you have to start the name. Okay. And the position of the substituents, the branches, second position and sixth position, and number 2 and 6, they have to be presented in the name. Now, what is the name of this compound? It is 6-ethyl, 2-methyl, no name. So, why it is a name like this? Why can't we name like a 2-methyl and 6-ethyl, no name? We can also write 2-methyl and 6-ethyl, no name, right? But why the name is given like this? Any idea for any of you? My question is, you can also write 2-methyl, 2-methyl and 6-ethyl. Very good, Jeevan. Very good. So we have to follow the alphabetical order. We have to follow the alphabetical order. So E comes first in the alphabet, right? So E comes first. That's why we are naming, giving ethyl the first preference. So 6-ethyl. And 2-methyl, no name. 6-ethyl, 2-methyl, no name. Okay. So 6-ethyl, 2-methyl. This part is your prefix part. And since we are having 9 carbon in the parent chain, what is the root word? Root word is nonane. This is the root word. And it is a hydrocarbon, right? So we have to end it with the primary suffix, which is called as alkane, A-N-E. Clear? Prefix, root word, and suffix. So this is your IUPAC nomenclature. Clear, students? Then next I'll go for, numbers are separated from groups by hyphen. So if you are separating a number from a letter, you have to put hyphen. In case of this, you see. So number and a letter has to be separated by hyphen. One number and another number, they have to be separated by comma. Got it? Number and letter by hyphen, number and number by comma. So this is the rule you have to follow. And you should not leave any space in your IUPAC nomenclature. Between your prefix, suffix and root word, you should not leave any gap. You have to write it as a single name. Then only it is correct. If different alkyl groups are present, they are listed in the alphabetical order. That's what we have done here. Coming to fourth rule, if 2 or more substituent groups are present, then they are separated by comma. If 2 or more identical groups. So in the last example, we had 2 substituents. One is methyl and the other one is ethyl. But if 2 are same, if 2 are methyl, if 2 are ethyl, then what we have to do? We have to separate them by the comma. You see, you need not give 2 methyl, no name. 3 methyl, 3 ethyl, decade, like that. You don't have to write. If there are 2 substituents, write di. If there are 3, give tri. If there are 4, give tetra, penta, hexa, hepta, octa. Like that it goes on. Okay. So for this particular compound, what is the parent chain? So straight chain is the parent chain. And to the second and fourth carbon, 2 methyl groups are attached. Now what is the name of this compound? 2,4 dimethyl pentane. So both the numbers are separated by comma. Here we are not using 2-methyl, 4-methyl pentane. We are writing 2,4 dimethyl pentane. Yeah. And in the second example, you see to the second carbon. So there should not be hydrogen here. And to the second carbon, 2 methyl groups are attached. And to the fourth carbon, only 1 methyl group is there. So totally we are having 3 methyl groups. What is the name? 2,4 trimethyl pentane. Okay. So this is your prefix and pent is the root word and ANE is the suffix. In one more compound you see. So parent chain contains 7 carbons, 7 carbon and parent chain contains 7 carbon. Why it is coming to this? Parent chain contains 7 carbon and to the fourth carbon we have 2 methyl groups and to the third carbon we have an ethyl group. CH2, CH3 is called as ethyl and these two are methyl. Okay. Now 3 ethyl alphabetical order, right? So 3 ethyl, 4,4 dimethyl, 7 carbons. So hept, alkane, ANE. Clear for all? Any doubt? Any doubt? From the fourth rule, find the parent carbon, number it. Okay. Then start naming it. If 2 same substituents are there, put di-tri like that. And if 2 different substituents are there, name the compound according to the alphabetical order. That's it. Clear? Shall I go with the next slide? Shall I go with the fifth rule? Clear up to 4 rules? So, okay, if you're having any doubt, you just ask me. So, coming to the fifth rule, if 2 substituents are found in the equivalent position, then the lower number is given to the one coming first in the alphabetical listing. So just see the compound, the first compound which I have explained for you in the first rule, the same compound, but with the, yeah, it is not the first compound. In first compound, we had 9 carbon in the parent chain, right? So this is different. So it has only 8 carbon. Fine. So we have 2 substituents. So this is your ethyl and this is your methyl. And while numbering from left to right, so what are the numbers I'm getting? 3 and 6 I'm getting. If you are numbering from right to left, so again, what we are getting for both the substituents? It is 3 and 6, right? So both are having 3 plus 6. Means both the substituents are found in the equivalent position. Then how to number? Which is the correct way of numbering? Whether we can number from either of the ways or which one is correct. So here you have to follow the alphabetical listing. You have to follow the alphabetical listing. So E comes first in the alphabet, no? So you have to give the first preference for ethyl containing carbon. So which way is correct? The first way is correct or the second way is correct? You guys tell me which is the correct way of numbering, left to right or right to left? First way, very good. So what is the name of the compound? It is 3-ethyl 6-methyl octane. And this is 6-ethyl 3-methyl octane. First is correct and the second one is incorrect. Clear for all? From each rule, we are learning one new concept, which you have to apply for the compound which you are getting in the question. All the rules cannot be applied for a single compound. Okay. You may not be using all the rules in a given particular compound. So you have to practice with many compounds so that you will get to know about it more effectively. So I hope all the 5 rules are clear to you. Then coming to the students, do any of you have any doubt in the rules? Shall I go for the cyclic compound nomenclature? Any doubt till the previous slide? No doubt? Shall I proceed? Shall I proceed? Okay. Okay, fine. Let's go with the nomenclature of cyclic compounds. So the saturated monocyclic compound is named by prefixing the cyclo, as we have already know. Okay. So here you can see there are 5 carbons, so it is called a cyclopentane. And what is the name of the ring present here? It is cyclohexane. But to the cyclohexane, 2 alkyl groups are attached. To the cyclohexane, 2 alkyl groups. So what is the name of this alkyl group? It is 1 carbon containing alkyl group, so it is methyl. And here in this alkyl groups, there are 3 carbons, right? So this particular alkyl group is called as propyl. This is methyl and this is propyl. Now, what is the first rule? First rule is finding the parent chain. So here we cannot find the parent chain because it is a cyclic system. So the second rule is giving numbers. How will you number? Clockwise or anti-clockwise? How to number? If I'm going up with the clockwise, I will start from here. 1, 2, and 3, right? So the substituent attached carbons, they are getting number 1 and 3. Okay, 1 plus 3 is 4. So this number I am getting. So just a second. So there is no power in my place. So I am turning off my camera. Once I get it, I'll turn on. Okay. So the number is 4. So 4 is 4 I'm getting if I'm going from clockwise direction. Okay. And if I'm doing from anti-clockwise, that is if I'm starting from propyl 1, 2, and 3. So again, you see what are the numbers we are getting? We are getting 3 and 1, which is again 4. So the same numbers we are getting if we are doing from anti-clockwise. So now you guys tell me which is the correct way of numbering, clockwise or anti-clockwise. Just now we have seen in the 5th clockwise. Think of it once again. In the 5th rule only we have discussed about this particular issue. if the substituents are having, getting equal number, then what we have to do? We have to look for the alphabetical listing, right? We have to look for the alphabetical order, no? Yeah. So who comes first in the alphabet? M or P? Methyl. Yes, you are right. You are right. Yeah, you are right. You are right, my dear. No, Anvisha. First M comes down, then only P. Your first answer was correct. So the answer is, you have to list it in the alphabetical order. So it is 1-methyl 3-propyl cyclohexane. Name of the compound is 1-methyl 3-propyl cyclohexane. Okay, this is the correct way. Correct. Okay. Can any of you give me the correct IUPAC name for this particular compound? I'll give you 30 seconds. You try the name for this compound and put it in the chat box. And then we will check whether it is correct or not. Let's see who is doing first. Has anyone got the answer? Has anyone got the answer for this question? None of you? None of you? Huh? Very easy, right? So see, just look for the substituents. So we have 2 methyl substituents attached to it. We have 2 methyl substituents, and what is the name of the substituent? It is ethyl. Okay. Now you have to number. Let me 1,3-diethyl cyclohexane. No, my dear, no, Jeevan. Okay, we'll discuss. Okay, just listen. So, to this particular carbon, 2 substituents are attached. Okay, so both are methyl. So let me number first in the clockwise manner: 1, 2, and 3. And to the first substituent, since I'm having, to the first carbon, since I'm having 2 substituents, I have to take the number 1 plus 1 plus 3. What is the answer? 5. For which direction? Clockwise direction. Okay. If I'm going for anti-clockwise, 1, 2, and 3, 3-ethyl, 1-methyl cyclohexane, Anvesha. Okay, let's check. Okay, whether your answers are correct. Let's check. So this is for anti-clockwise. So for anti-clockwise, 1 plus 3 plus 3. So what is this? 3 plus 3 plus 1, 7. So which is the correct way of numbering? We have to get the lowest possible number, no? So 5 is the lowest number and clockwise direction is correct. Anti-clockwise direction is wrong. So let me erase the anti-clockwise numbering. Okay, this numbering is wrong. Then what we have to do? I have to start naming the compound. Naming has to be done in the alphabetical order. And E comes first in the alphabet. So the name will be 3-ethyl 1,1 dimethyl 1,1 dimethyl, and the ring contains 6 carbon. So it is called as cyclohexane. Got it? Clear for all? Clear? Any doubt? 3-ethyl 1,1 dimethyl cyclohexane. Clear for all, my dear? So if substituents are, if 2 substituents are same, then you have to give di-tri, no? That's what we have discussed in the 4th rule, right? You guys have forgot, or I don't know. Okay, no problem. Since this is the first class for nomenclature, you don't have to worry about it. Just go through the rules. I think and I hope you all are taking the notes of the class, or at least the screenshot you're all taking. Am I right? You guys are taking the screenshot or the written notes, no? Yes. Good. So try to take the notes or the screenshot and revise it. Very good. Good. So revise it before coming to the next class. everything will be all right. If you're getting any doubt, you can ask me in the next class. Clear? So you can see two compounds and the name is also shown to you. But anyway, see, parent chain is found out and there are 3 methyl groups attached to it in the second, fifth and sixth position. So 2,5,6 trimethyl octane and here ethyl and here it is methyl. So go with alphabetical listing. So 3-ethyl, 5-methyl, heptane. So here if you number for the second compound, if you're going from left to right, you will get same 3 and 5. For right to left also, you will have 3 and 5. So in that case, you have to follow the alphabetical listing, right? So that's why left to right numbering is followed here. Clear? So the nomenclature of compounds with one functional group concept topic I'll discuss tomorrow. Clear, students? So hope, so today we have discussed the common names, which is also called as IUPAC name. So what is the summary for today's class? We have discussed you the common name. And secondly, we have discussed the IUPAC nomenclature. In the IUPAC nomenclature, the main components are prefix, the root word and suffix. This is the skeletal structure. Got it? And in the IUPAC nomenclature, for straight chain hydrocarbons, we have named, and for branched system also, unbranched and branched. For branched system also, we have seen the nomenclature. For branched, we have to follow some rules, and we have seen 5 rules under it. And lastly, we have seen the nomenclature for cyclic compounds also. Okay. So tomorrow we will go with the nomenclature for the system which are having functional groups. Clear? So study till today's part and come for the next class. Solve more number of questions. Okay. Any doubt, student? If you're having no doubt, then I'll meet you in the next class. Thank you so much for all of you for listening the class. Thank you. Thank you, Anvisha. Thank you. Thank you so much.